Welcome back, friends. In today's class we will learn about the method of sections, and I wanted to find the load in member BC, BG and EG. I wanted to find the forces in these members, and before I start finding the forces in these members, what I like to do is always like to find out the reaction loads first. So this is a pin joint, so I'll draw the reaction load. This will be RCY, this will be RCX, and then this is a roller joint, so I'm gonna show only vertical forces RAY in here. And then I can find the component of this force also. This component will be 52, vertical component of this inclined force will be 52 times 5200 times 12 over 13. Why 13? Because if this is 12 and this is 5, this slope will be 13, and I can apply the Pythagorean theorem and can find this value as 13. So this value comes out to be 4800, and then if I wanted to find the horizontal component, this will come out to be 5200 times 5 over 13, which will come out to be 2000. So I have found out the components of the force given to me. Now what we wanted to do is we wanted to find the reaction loads. So I'm going to write the equation sigma f of x equal to 0 and sigma f of y equal to 0, and then there is a moment equation also, which we'll talk about later on. So I can write RCX, which is acting in the negative direction, plus this 5200 is acting in the right direction, so I'm gonna use the positive value. So this is two component of 5200, shall I say 2000 equal to 0. So RCX equal to negative 2000. This is the value I'll get for RCX. And if I write the equation for the vertical component, so it will be RAY plus RCY equal to 4800, and all are negative. So what I can do is just to correct this equation. This is also correct equation, but I'll write it in a simpler version. Anything in the downward direction we consider it as negative. This is downwards, we consider it as negative. So negative RAY, negative RCY, negative 4800. That's how I'm gonna write it, equal to 0. So this is RAY. I'll take negative common from these two, plus RCY equal to, this goes on the other side, becomes 4800. So I can now RAY plus RCY equal to negative 4800. This will be my equation. Now once we've written down these two equations, I will take the moment about point C, because there are two forces acting, two reaction loads acting at point C. So I'll take the moment about C. So taking moment about C. So RAY, which is trying to rotate it in which direction? Counterclockwise direction. So this value will be positive RAY times 8, because the perpendicular distance from point C is 8, and then this vertical force, this is trying to rotate it in clockwise direction. This one is clockwise direction, so this will be negative. So negative 4800 times 4 equal to 0. So RAY equal to 4800 times 4. 4800 times 4 will give me 19200 divided by 8. That's gonna give me 2400. So I figured out RAY, and if I know the value of RAY, I can find RCY also. So RCY value will be negative 4800, negative 2400. So 4800, this will come out to be 72, negative 7200 RCY value. So these are the values which we figured out for our reaction loads. So I'm going to write them at a side. RCX comes out to be negative 2000, and then RAY came out to be 2400, and RCY came out to be negative 7200. Now what I'm gonna try and do, I'm gonna make some space for myself and try to simplify for the load in members, or the forces in members in this case. So let's write down. So what I'm going to do is I'm going to cut it. So when we are doing the method of section, we try to cut the section in such a way that we can cut the maximum number of members about for which we wanted to find the loads. So this question becomes relatively easy. If I cut it from here, I will cut all the members for which I wanted to find the load or the forces. So I wanted to find the forces in BC, I wanted to find the force in BG, and I wanted to find the force in EG. So if I cut it from here, I will be able to cut all the sections for which I wanted to find the force. And now let's write down let's first of all draw the free body diagram. So you can take this portion also, or you can take this portion also. I'm going to use this portion because there are less number of forces in this one and there are way more forces in this one. So this, if I consider this section, my question will become easier. You can choose any section, the answer will still remain the same. So now if I take this load, this is acting in the RAY, is acting in the downward direction, then I draw a free body diagram. It will be like this, and then this will be like this, and then this is like this, and this is BC, and then this is BG, and then there is something in this direction which is E. This will be, if I join dotted line, this will be G again. So I wanted to find the load in these members, or forces in this members. Now let's start solving this now. So if I take the moment in these, we use in the method of section, we use a moment equation a lot. So if I take the moment about point B, or if I take the moment about point G first of all. So if I take the moment about point G, what I can do is I can easily find BC, because these two forces, I don't need to find the load in members in BG and EG if I'm taking the moment about point G, because they will nullify, and then I will be easily able to find the load force in member BC. So RA, let's write down the equation. Taking moment sigma m G equal to 0, taking moment about point G. So RAY times perpendicular distance is 8, which is counterclockwise, and this is trying to rotate it in which direction? Clockwise direction. So minus 3 times, 3 is the perpendicular distance, BC, and which is equal to 0. So RAY value is 2400 times 8 minus 3BC equal to 0. Then BC value will come out to be 2400 times 8 divided by 3 comes out to be BC value, negative BC comes out to be, this is negative of 6400, and I can cancel these, and BC value will be, BC comes out to be 6400. I figured out the BC value now. Now what I'm going to do is I'm going to try and find the the forces in the remaining members. I don't know why I keep calling the load, because usually it's not given in newtons, so that's why. And now let's find the force in member BG and EG. So if what I can do is, now I can take the moment about point B. So if I take the moment about point B and write down the equation, so it will be EG times, I can say EG times the perpendicular distance is 3, and then this BG is passing through point B, so this will become 0, and then I can easily find out the value of EG now. So this EG times 3, and RAY This is trying to rotate in clockwise, counterclockwise, so this is positive, and RAY value is also positive, so this is positive 2400 times what's the value here? The perpendicular distance is 4 equal to 0, so 2400 times 4 and divided by 3, and that will be EG value will come out to be negative 3200. Now we calculated this value of EG, and I only wanted to find BG now. So how can I find the value of BG? That's what I need to look into. So that portion, so the video is getting a little longer, so I'm gonna solve for that portion in my next video. Hopefully you were able to understand this part. In the next video I'll solve for BG. Have a good day. Bye now.